Science often starts when we observe something and it makes us wonder. One way to explore the questions we have is to use the scientific method. But what is scientific method? The scientific method creates a framework for logically and systematically experimenting in order to find answers. This has several steps including making observations, formulation of hypotheses, testing of hypothesis, experimentation, and drawing of conclusion. In this video, we will look at each step of the scientific method in much more detail.
Step 1. Making observations and gathering knowledge about a phenomenon.
It is the initial observation, recognition of problem, and defining it, further observation, and expanding knowledge. As scientists conduct their research, they make observations and collect data. The observations and data often lead them to ask why something is the way it is. Scientists pursue answers to these questions in order to continue with their research. For example, when you're a plantito or a plantita, and you observe that your plant's growth is slower and not that healthy. So you decided to use fertilizer, but you don't know what fertilizer you will use. So you buy an organic fertilizer and an inorganic fertilizer.
Step 2. Formulation of hypothesis.
Developing a hypothesis prompts a thorough understanding of the research topic as well as an extensive review of the previous literature and evidences. It is essential that a relationship between variables be discovered, but it also needs to be predicted using a theoretical guidelines and empirical evidences. For example, soil fertility depletion. It is a major issue in many countries when it comes to sustaining agricultural production and productivity. The use of inorganic and organic fertilizer alone has an impact on the plant's growth, nutrient availability, and soil health. Organic fertilizer strengthens the soil's physical and biological activities, but it has a low nutrient content, so a larger quantity is required for a plant growth. Inorganic fertilizer, on the other hand, is usually immediately and rapidly accessible, containing all the necessary nutrients that are directly available to the plants. However, the sustained use of inorganic fertilizer causes soil organic matter degradation, soil acidification, and environmental pollution. In conclusion, the plant with organic fertilizer will grow healthier than the plant with inorganic fertilizer, as organic fertilizer has a better composition and texture, and it is much more efficient in the long run.
Step 3. Testing of hypothesis.
Just like you've learned in science class, hypothesis testing is the process of making an observation, forming a question based on the information that you've gleaned, and then attempting to solve that problem using the scientific method. That's the simplified version. The beauty of the scientific method is that it's gradual and deliberate, and each phase is recorded, and your hypothesis continually altered until you've come to a solid enough conclusion. For example, in this scenario, you are going to test which fertilizer works the better. Is it inorganic or organic fertilizer? This will take time to observe and to test, but surely time will tell which fertilizer is better for your plants. And by that, we will come up to a conclusion.
Step 4. Experimentation.
Next is test your hypothesis by doing an experiment. Your experiment tests whether your prediction is accurate and thus your hypothesis is supported or not. It is important that your experiment to be a fair test. You conducted a fair test by making sure that you change only one factor at a time while keeping all other conditions the same. You should repeat your experiment several times to make sure that the first result weren't just an accident.
Wow! Based on the result of the experiment, organic fertilizer works the best. Step 5. Drawing of conclusion.
And finally, the last step, drawing of conclusion. It is the analysis of data to determine whether the hypothesis is supported or not. And it is also the publication of results. And did you know that data are results of the experiment which may lead one to accept or reject the hypothesis initially formulated? This should be observable and objective. Mathematical data are usually presented in tabulated and graphical forms, may require statistical analysis to confirm validity or significance.
A conclusion is the answer to the problem, and based on the supported hypothesis, science is the progressive process such as the conclusion of one experiment can lead to the hypothesis for another experiment. The results that do not support the hypothesis may be used by the scientist to formulate another hypothesis to be tested.
Conclusions from many different but related experiments may lead to development of a scientific theory, a general concept about the natural world. A theory, therefore, is a hypothesis that has been repeatedly and extensively tested and always found to be true. However, no theory in science is ever absolutely and finally proven. Scientists should be ready to alter or even abandon their most cherished generalizations when new facts contradict them. By Keaton and McFadden, 1983.
For example, after you find out the result of your experimentation, you concluded that your hypothesis is accepted because the result shows that the plant with organic fertilizer grow much more healthier and improve the quality of the soil even though it's slower in growth speed than the plant with inorganic fertilizer. Also, this experiment come to an end that it is much more better and safer to use organic fertilizer than the inorganic fertilizer.